Okay, tricky exponents and graphs. Let's go ahead and get started. Number one, I know it's hard to see up here, that's why I gave you a handout, so read it on your handout. The value of an antique car is modeled by the function v of x equals 107,000, 1.009 to the 2/3 x, where x is the number of years since 2005. By what approximate percent rate is the value of the car increasing per year? All right, what is the question asking for? Very good. So circle that. They're asking for the approximate percent rate. That's what they're asking for. Circle that. From what you learned yesterday, does 107,000 have anything to do with the percent that it's increasing by? No. What's 107,000? The starting value. So mark that out. That has nothing to do with today's problem. This one, they've thrown a little wrench into it because they don't just have an x up at the top. What else do they have with the x? A 2/3. They've added an extra number. You have to deal with that extra number. It's pretty simple though. In your calculator, you're just going to type in parentheses 1 point, so I'm typing in what's in parentheses, 1.009, parentheses, then use your caret key, and you're going to put in the 2/3. You don't put in the x. You don't put in the x. So you put in 1.009 to the 2/3, and you press enter. And so now what really is there is 1.006 if you round it. So we put in both those numbers in the calculator, and we got 1.006. Now think about what we did yesterday. How would we figure out what percent that is if that's what they had in parentheses? Good. This is bigger than 1, so it is increasing. How do I figure out, though, what the percent is? What did you have to do yesterday? Minus 1. Minus 1. So, in my calculator, I would minus 1 from it, and you get that, 0.0059, or you could round it. You always take 1 away, and here's why. To get this, remember the formula that they used was 1 plus r. Since it's increasing, they used 1 plus r, right? We're trying to figure out what r is. So we're taking away the 1 to see what we're left with. Okay, good question.
When it's increasing, wouldn't it be easier just to just take the 1 out and just move the decimal to rather than typing it in the calculator?
Yes, you could do it without the calculator if it's increasing, yeah. And that might be easier for other people. Some people like to do the same steps every time. So it just depends on what you like. Okay? So we subtracted 1 just like we did yesterday, and we got to do one more step kind of in our heads. What do you have to do with this number? How do you make it a percent? You move the decimal. You could also, someone showed me this yesterday, you could times it by 100, and it would make it a percent for you. You could times it by 100. So you get 0.59, and if you look at your answer choices, they've rounded it to what? 0.60. All right, so that's the answer to C. Number 2, the value of an antique toy car is modeled by the function v of t equals 5, parentheses 1.008 to the 1/2 t, where t is the number of years since 1965. Approximately what percent rate is the value of the radio increasing each year? Riley K., what's it asking for? The percent rate is what it's looking for. Madison, does the 5 have anything to do with it? No, so I'm going to mark out the 5 so it doesn't confuse me. This one has an extra number. I know it's really hard to see up here, but do you see on your papers where it has a 1/2 with it? So you have to put those in your calculator to take care of it. So parentheses 1.008. Do this with me, please. Parentheses 1.008. You got to use the caret key to the 1/2. Okay. Faith, what other steps do I have to do? Good. I got to take 1 away. And then I need to make it a percent. So you could move the decimal 2 places, or you could times it by 100. Could times it by 100. All right, Stephen R., what does 0.39 round up to? 0.4, so that one is D, 0.40. Any questions? Okay. Number 3, the value of a house in your neighborhood could be modeled by the function f of x equals 120,000, 0.92 to the 1/3 x, where x is the number of years since 1995. By what approximate percent rate is the value of the car decreasing each year? Riley M., what is it asking for? Good. It's asking for the percent. Elijah, does 120,000 have anything to do with the percent? No, so I'll mark it out. Brandon, what am I typing in my calculator? This one, number 3. All right, to the 1/3 power. To get that. Shakira, what else do I have to do with that? You've got to subtract 1. You got to subtract 1. Don't worry about it being negative. Okay. The negative just means that it's decreasing. And didn't they already tell you that? See, they already told you it was decreasing, so you don't need to worry about the negative. Okay. All right, and Zach, what about 0.02? What do I need to do with that? All right, and so it becomes what? How many times do I move it? 2, so it becomes 2.7, which rounds up to 3. Rounds up to 3%. All right, number 4, the value of a diamond ring has been in your family for generations, can be modeled by the function f of x equals 10,000, 1.002 to the 4/3. Is that 4/5? 4/5 x, where x is the number of years since 1960. By what approximate percent rate is the value of the ring increasing each year? Brayden, what's it asking for? Good. Please circle that. Always circle what the question's asking for. Riley M., does 10,000 have anything to do with the percent rate? No, so I'll mark it out. Hallie, what am I going to type in my calculator? $1.002 to the 4/5. Okay. Zach, is there anything more I have to do with that? Good. Got to take away the 1. And Stephen A., what else? I got to make it a percent. How do you do that? Good. How many places? Twice. Guys, look up here real quick. When I move the decimal 2 places, it's going to be point what? 0.15, or you could round it up to 0.16. Okay. So that one is C. All right, any questions on those first 4? All right, these next ones have graphs. This 5, is the x with the 5? Yes. Is 5 my starting value? No, because it has an x. What can you multiply in front of 5 to keep it the same? A 1. Put a 1 on your paper, please. Put a 1. Put a 1 in front of it. 1 is my starting value. What's the other term for starting value? Y-intercept. So this is the Y. So I put a point at 1 on the Y. Since the x is up high, that makes it exponential. Or exponential straight lines or curves? They're curves. And you look right here. Is 5 bigger or smaller than 1? Bigger. So that makes it increasing, and it's going to be a curve. So we're just doing rough sketches. All right, number 2, 1/3 to the x. Elijah, is 1/3 my y-intercept? No, what is my y-intercept? 1, so I put a 1 in front. So this is on the side of your paper, guys. It's on the left-hand side, the 1/3 to the x. So Samaria, what point do I put on my graph? A 1. Shakira, is this linear or exponential? So that makes it a straight line or a curve? A curve. Good. And 1/3. Madison, if you multiply something by a third, does it make it go down or go up? Multiplying something by a third leaves you with only a third of it left, so it's going to make it go down. 1/3 is less than 1, so that makes it decrease. So your curve is going to look like that. Curve's going to look like that. All right, we're going to do more. We're going to practice more. Okay, so this one, number 1 now, it says 3 to the 2 to the x power. So back up on that first row, number 1. Jeremy, 3 is my what? How do I label that? Is it my starting value, or does it tell me whether it goes up or goes down? It's my starting value, which is also my y-intercept. So I'll put a point at 3. Jack, is it going to be a curve or a straight line? Good. And Riley K, is it increasing or decreasing? Increasing. If what's in parentheses is bigger than 1, it makes it increase. So it's going to look like that. Stephen R., what is the 2? How do I label it? It's my starting value, which is also my y-intercept. So I'll put a point at 2. Faith, is this one increasing or decreasing? Decreasing. Why? Good. So it looks like that. So if they're increasing, it just goes up to the sky. If it's decreasing, it levels off at 0. All right, number 3. Jeremy, what's my starting value? 5, and that's also my y-intercept. Elijah, is it increasing or decreasing? Good. Why? Very good. And Riley M., what's my y-intercept on number 4? 4. Hallie, is it increasing or decreasing? Why? Good. All right, number 5. They've added an extra number. They've added an extra number. Does -4 have an x with it? No, -4 affects your starting value. -4 affects your starting value. To get your starting value, you now have to do 3 minus 4. You now have to do 3 minus 4. What is 3 minus 4? So my starting value is -1. My starting value is -1. So that -4 has shifted it. It shifted your graph down. Okay? So your starting value is -1. And then the other rules still apply. So Riley K, would this one be increasing or decreasing? Increasing.
How did you get the -1?
So my starting value was 3. And then they put a -4 at the end, and that affects your starting value. This -4 pulls the graph down. So you have to put these numbers together. What is 3 minus 4? -1, right? All right, number 6, Madison, what does the +3 affect? My starting value or whether it's going up or going down? Okay, so the +3 affects my starting value. These are the two without the x. What is 2 plus 3? 5. So my starting value is 5, which is also my y-intercept. So I'm going to put a point at 5 on the y. 1, 2, 3, 4, 5. And Faith, is it increasing or decreasing? All right, so on number 7, Jack, what would be my starting value?
-3.
Yep, -3. You got to do 5 minus 8 to get -3. 5 minus 8. Steve Nate, is it increasing or decreasing? Very good. Number 8, Samaria, what would be my starting value? Very good. 4 minus 4 is 0. Where's 0 on the graph? In the center. So you just put a point at 0. That's fine. You can have a point at 0. And the 2/3, is that less than 1 or bigger than 1? Less than 1, so it makes it go down. All right, any questions on 5, 6, 7, or 8? All right, number 9, the function f of x equals 3 to the 1/2 x was replaced with f of x plus k, resulting in the function graph below. What is the value of k? All right, so this is a weird way to ask it, but it's not bad. This was the original function. This was the original. What was the y-intercept of that original function? 3. 3 was the y-intercept. So the y-intercept was 3. The y-intercept was 3. So I'm going to put a point at 3 on the graph. That's where it originally was. So that's the original one. Okay, so I'm going to put a point at 3 where it originally was. Now they've replaced it with this one, this curve. What is the y-intercept of this black curve? Where's it crossing at? -6. So this is the new one. Okay, so the original crossed at 3. Came from right there. Original crossed at 3. And the new one crosses at -6. They want to know what number you have to tack on to change it. So it was at 3, and then it's going down to -6. So look, they moved it up or down. They moved it down. That's going to make it negative. And you count the blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. They moved it down 9. So -9. And here's exactly what happened. So if I take this function, 3 to the 1/2 x, and I put -9 here, instead of it being at 3, now it's 3 minus 9. What's 3 minus 9? -6. Okay. Number 10, the function f of x equals 3, 4 to the x was replaced with f of x plus k, resulting in the function seen in the graph below. What is the value of k? All right, so Zach, what's my original y-intercept? 3. So I'm going to put a point at 3, and you could call it the old one. That'd be shorter to right. So I'm going to put a point at 3. And I'm going to label it the old one. Jack, what's my new y-intercept? Which is at what number? 2. Okay, so my old one was at 3. My new one's at 2. It's important to label them because you're going to go from the old to the new. You got to go in the right order. We got to go from the old to the new. Brandon, how do you go from the old to the new? Subtract how many? 1. So your answer is -1. Go from the old to the new. Number 11, the function f of x equals 2 to the x was replaced with f of x plus k, resulting in the function seen on the graph below. What is the value of k? Okay, this one is tricky. You just have to remember. Is 2 my y-intercept? No, because it has the x with it. 2 is not my y-intercept. What is my y-intercept? 1. You've got to put the 1 in there. So the y-intercept is 1. So I'll put a point at 1, and that's the old y-intercept at 1. Not 2, but 1. All right, Shakira, how do you go from the old one to the new one? Subtract how many? 4. So -4 is your answer. Okay, number 12, a function is graphed below. What is the function? Okay, well, the easiest thing to look at, or one important thing to look at, is what? What's one important thing to know? Where's the starting value? Very good. So my starting value is -3. My starting value is -3. All right, so let's look at A. Is 3 the starting value? No. What do I need to put right here? A 1. I also have to do something with that 1. What else do I have to do with the 1? How do I get the starting value of this one? I got a 1, and I have to subtract 3 as well because it doesn't have an x. So what is 1 minus 3? -2. So on A, the starting value is -2. Is that what I want? No. Okay. All right, I'm going to go to C. So Madison, help me find my starting value of this one. What do I need to put in front? A 1. What else do I have to do with the 1? From -3. So what's 1 minus 3? -2. So the starting value on that one is -2. So I don't want that one either. Okay. On B, Riley M, what number do I need to put right here? A 1. And what do I have to do with the 1? And that gives me -3. So that one is B. And the last one. What is the y-intercept of the graph? 2 to the 6x plus 5. Shakira, help me with that one. So the y-intercept is 7, which is C. Okay. Questions? All right, on your own.